Command line parameters are a way to pass information or data to our program when we run it from the command line. This practice is very common in languages like C++, but it's also entirely feasible with Node.js. It's especially useful if we use Node.js for local development scripts that interact with a local file system. While it might not always be essential when we develop a web server using Node.js, understanding this functionality enhances our grasp of Node.js, and it's definitely worth knowing. The best part about working with command line parameters is how easy it is. So, let's begin by removing our package.json file and our Node modules folder, because we don't need any external modules to work with command line parameters. Later on, we will see how we can use modules to enhance our experience. But for now, we want to keep things simple and basic, which means no external modules for now. To access our command line parameters, we simply utilize process.argv. That's it. This is essentially all we need to know to get started with command line parameters. Let's log the value of process.argv. When we run our program normally, using node followed by the name of the script without any other arguments, we can see that the value of process.argv is an array. This array contains two initial values. The first is the full path to the Node.js executable itself, indicating where Node is installed. The second value in the array is the full path to the script we're currently executing. Since we just ran the app script, we can see its full path. These values are always there. They don't contain any additional information. This is not considered real command line parameters because they are constant. The real power comes from our ability to add extra parameters, sending more information alongside the script we want to run. So, let's try sending the value test param. If we run the program this way, we can see that our process.argv array has changed and now contains test param, the parameter we just sent from the command line. This represents a real command line parameter. It's important to note that command line parameters are always strings, which is why our array contains the value of this parameter as a string. We aren't limited to just one command line parameter. We can pass as many as we want, so let's try passing two parameters and name them param1 and param2. We can see our array updates accordingly, now containing our two command line parameters. As we observed, the first two values in the array are constant. The first one is the full path to the node executable, and the second one is the full path to the script we're running. This is why, in some situations, we might prefer to ignore those initial two values and focus only on the remaining parameters. To do this, we can slice the argv array. By using the slice method, we can extract only part of the array. If we pass 2 as the argument to slice, we end up with an array that doesn't include the first two elements. Running our program this way shows that we no longer have the initial two parameters, and we can see only the actual data that was sent to the program, param1 and param2. It's common to pass command line parameters as flags. This isn't required, and, as you saw, command line parameters can be any string. However, many developers prefer the double dash convention. Command line parameters that start with 2 dashes are typically used as flags, helping configure how we want our program to execute. For instance, if we want to run our program in a specific manner or alter its behavior, developers often incorporate flags as options for program execution. So let's say we want to use a flag. It might look something like this: --flag, where flag is the name of the flag being passed to the program. Now, the idea here is that a flag can either be defined or not defined. Sometimes, users will run the program with a flag, and other times, they might run it without. It makes sense to check if the flag was passed to the program. As we know, the first two elements in the argv array are constant and don't provide real information, which means the actual flag is expected to be found at index 2. Let's check if index 2 of our array contains the flag we're expecting. Let's say flag 1. If it exists, we know that flag 1 is on. Running our program this way and passing flag 1 shows that flag 1 is indeed on. But if we pass flag 2 instead, we won't see anything in the output because flag 1 is no longer on. The next step is to pass an actual value to the flag, because sometimes flags can have associated values. I'll implement that by passing the flag's value as a different command line parameter. This means that the array element at index 2 will be flag 1, while its value will be at index 3. So if we send flag 1 as a parameter, we will display its value, located at index 3. Let's run the program again, passing the value 7 as a separate command line parameter, thinking of it as the value for the flag1 flag. When we run this program, we see the output, 7, indicating that flag1 is indeed active and showing its value. To clarify this further, let's add support for flag2. If flag1 is sent, we will display the value of flag1. If flag2 is instead sent, we want to indicate that a value was sent for flag2. Running the program this way with flag1 shows that its value is 7. But if we send flag2 instead of flag1, we can see that the value reflects flag2. Next, I want to showcase an npm package that's extremely helpful for working with command line parameters, and especially flags. So, before we install this npm package, let's run npm init, which will create our package.json file. Now that we have initialized the project for npm, we can install our package called yargs. To install it, we'll run npm i-yargs. If we open our package.json file, we can see it listed under dependencies. And we also have the Node modules folder, which contains everything we need for this package. To get started with yargs, we first need to require it. Let's define a constant that will store what's returned from requiring yargs. Here's the important part. Yargs returns a flags object. To retrieve this object, we need to call yargs and pass our process.argv array to it, followed by .argv. By using this syntax, we'll have an object that makes it easy to access all of the flags sent to the program during execution. Let's start by logging the flags object. When we run our program and pass a flag, say flag1, we can see that we now receive an array containing the initial 2 elements we've already seen, plus the actual flag sent, flag1. We also note that its value is true. Every flag passed as a command line parameter will be defined in this object, and its value will be true. Let's try passing another flag and name it test. We can see that this flag is also present in the returned object. Both flags, flag1 and test, are now defined, and their values are true. However, we aren't limited to just defining flags as true. We can also assign values to them. The yargs package expects the value attached to the flag to be separated from the flag name by an equal sign. Let's say we want the value of flag1 to be equal to 7, written as equals 7. Similarly, we'll assign the value of the test flag to 33, written as equals 33. Running the program this way shows that flag1 and test no longer equal true, but take on the values we assigned. Since the flags exist in the returned object, accessing them is straightforward. Simply reference the flags object to get each of the defined flags. Let's log the values for flag1, flag2, and flag3. Running the program and passing all 3 flags along with their respective values shows that each flag's value is displayed as expected. If we don't define one of the flags, say we only define flag1 and flag2, we'll find that flag3 is now undefined. As a small detail to mention, if you refer to the yargs package documentation, it's recommended to require it using yargs. Although it still works the way I did before by simply requiring yargs, following that guidance is the best practice. Now, let's develop a simple task manager system that allows us to add tasks as command line parameters. This system will save the tasks added by the user into a JSON file. Since we'll be working with files, we first need to require the fs module. Let's create a function which we'll call updateJSON. This function will accept a task, which represents the data we want to save in our JSON file. It will be a straightforward process where we write synchronously to our tasks.json file. What will we write to this file? We will write the JSON representation of the task that was passed as a parameter, using json.stringify to convert the task, expected to be a string, into a JSON string. If a flag called newTask was passed to our program, we call this function and pass the value of the newTask flag. Let's run our program and provide a command line parameter for the newTask flag. We'll give it the value feedTheDog. Upon running our program this way, we can see that our tasks.json file is created and the task we provided now exists in that file. If we rerun the program and change the task from feedTheDog to feedTheCat, we see that the JSON file updates accordingly. I don't want only one task in my JSON file. I want to allow multiple tasks. Every time the user passes a new task using a command line argument, I don't want to replace existing tasks, but append to them. This leads us to work with an array. Let's define an empty array called nodes. This array will initially be empty, but should contain all tasks added in the past if tasks are already present in the JSON file. To achieve this, we first check if the JSON file exists. If it does, we should initialize our array with its contents. We'll utilize json.parse to convert the JSON data into an actual JavaScript array. To read the JSON string, we can use readFileSync, passing the JSON file to it. This will retrieve the JSON string, which can then be parsed to produce the existing array of tasks. Now that we're working with an array, we don't need to accept a single task as a parameter anymore. When we update the JSON file, we want it to contain all tasks from the array, not just one specific task. Thus, we'll stringify the entire array for saving. If the new task flag was passed as a parameter, we will append the new task to the already existing array before updating the JSON file. Let's remove the existing tasks.json file, and upon running our program again, the file is recreated. This time, the task is presented as part of an array. Although it only contains one task currently, we can easily add more tasks. Let's run the program once more, adding the feed the dog task. The JSON file updates successfully with all tasks appearing. Right now, all tasks are represented in one long line, which could be difficult to read. To improve readability, we can pass two additional parameters to json.stringify, undefined, and the number of spaces for indentation. Let's say 2 spaces. This will create a more organized JSON representation. Let's try adding an additional task, for example, mow the lawn. When we run the program again, we can see that the JSON file is updated with each task appearing on its own line. Next, we'll implement the functionality to remove tasks. This will allow users not only to add tasks, but also to remove existing ones. If the remove task flag is defined, we will remove the element at the specified index from the nodes array using the splice method. The first parameter to splice will be the index passed in the remove task flag, and 1 as the second parameter. Since we want to remove a single task before updating our JSON file, it's worth noting that command line parameters are always strings, and this includes when using the yargs package. Therefore, to use the value of the flag as an index, we need to convert it to a number first. Running the program while sending the remove task flag with a value of 1 updates the file and removes the task at index 1. One small thing to be cautious of is that if we attempt to remove the task at index 0, it may lead to a problem because if the flag value is 0, it could be interpreted as false, and the corresponding block won't execute. To avoid this, you can ensure that the flag is explicitly defined and not undefined. This way, even with a value of 0, the task at index 0 is still removed. This lets us use both flags simultaneously, so we can, for example, add a new task like feed the cow while also removing an existing task, say the one at index 0, and we see the JSON file updates accordingly. We can even render our tasks as HTML. Using our task list, we can generate a visually appealing HTML page. I'll define 2 constants containing HTML code, header HTML, which has the HTML code for the top of the page, and footer HTML, which has the code for the bottom of the page. Note that my header HTML includes an opening UL tag, which is closed in the footer HTML. Now that we have our opening and closing HTML tags, let's convert our tasks into HTML. We'll define a variable called notes.html that will store the HTML for the list items, where each will represent one task. We can iterate over the tasks in our array and append the text of each task into notes.html, wrapping it in an li tag. Once completed, we'll have the HTML code for all tasks. The last step is to concatenate everything. We'll create an HTML page to contain all necessary code: header HTML, notes HTML, and footer HTML. Once everything is prepared, we'll write this code into a new HTML page, which we'll name generatedpage.html. The nice thing about this setup is that even if no flag is passed to the program, the HTML page will still be created. Command flags are only necessary for adding or removing tasks. Let's run our program and verify that the HTML page was generated. Here is the code. You can see a list item element for each task. We can display this HTML page in the browser. Let's add a new task and remove an existing one. Then refresh the HTML page to see that it accurately reflects the updated tasks list.